So in addition to everything we've been doing this evening, we can also have something called a conditional statement. This is when you're given one piece of information and then you're basing something else off of it. A lot of times we also call these if-then statements or if and only ifs, which we'll get to in a few minutes. We denote these by as we would call it P then Q, or in other words, if P then Q. In the book, you'll typically see just an arrow. However, Smart Notes only has this little double arrow. It means the same thing. The only combination of circumstances which you can call a conditional sentence false is when we have a true hypothesis and then a false outcome. You can think of this as, if I do my homework, I will ace the test. Well, what happens if you do your homework and you still fail the test because there were other factors involved, such as maybe you were sick that day and you just didn't do well on the test? All of these should be taken into consideration, and let's go ahead and fill in our if-then chart to get a better idea of that. Notice here that we have our standard P's and Q's filled in. If something is true and then you get the desired outcome, this would be a true statement. If it's true, as we just mentioned before, if it's true and then false, maybe, again, going back to the test idea, you do your homework but you don't do well on the test, that would be a false if-then statement. If you go in saying, well, I didn't do my homework, but I still aced the test, well, hey, you got lucky and that's still a true statement. And then if you start out with a false statement and you get the same old statement, essentially you went into it knowing you were going to fail if we go back to the test reference. So if you go into the test thinking, I didn't do my homework, I'm going to fail. If I didn't do my homework, I'm going to fail. Or then, however you want to phrase it, then this is actually still true, as odd as it seems. If we look at this next example, if I eat my vegetables, then I get to stay up late. Yeah, how many kids say that? You would hope so, but first we do, of course, to verify this with the truth table, we have to first convert it into an if-then statement using logic. So let's say if I eat my vegetables as P, then I get to stay up late would be Q. So this is going to be our standard PQ, P then Q table. Again, let me just fill this in real quick. As before, any if P then Q statement, the table still ends up being the same. True, 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 false, 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 true, true, and false, false gives us another true. Now we look at an example where we have a disjunction, a not, and an if-then statement all in one. Let me start by filling this in. In this case, we're going to need our standard PQ, not P, not Q. P disjoint, not Q. And lastly, the entire statement all in one. P disjoint, not Q, then not P. Let me start out by filling this in. One thing we need to make note of here is how important at this point we should really have at least P's and Q's. We should definitely know those by now, or at least within a little bit more practice. This is, again, the standard fill-in of the table. It will be provided on the test. However, you won't have to provide the rest of the headings. So on a test, you'll be given these two columns filled in already, and then everything else is up to you. As far as the rest of this, we have to get comfortable with the knots. You've noticed now that they do come up quite frequently. And with that, I'm going to go ahead and fill in the rest of this table. So P disjoint not Q, we look at our P and our not Q column. True, false is true. True, true, true. False, 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 true, true. In addition to that, now we need to look at, this is where it gets, of course, a little more complicated. And definitely on a test, you're always more than welcome to use highlighters, colored pencils, anything that makes this easier for you to construct and look at. So here is our if-then statement. False, true. Well, that is a true statement because we ended up with our desired outcome. False, true, still true. True, false. Well, what did we say about this? This is like our undesired outcome, so this is our only false possibility. And if true, then true. So we end up with true, true, false, true. Again, the more practice you get with these, they will start to definitely become a little bit easier to work with, and you'll start to pick up on the patterns relatively quickly. A few more things we need to talk about this evening are if we're given a statement, how can we look at a couple different conditions of this? So we have definitely our negation, so negating the whole statement. Recall this is, where we could use De Morgan's law. However, with if-then statements, we do have a specific thing we use. Contrapositive, inverse, and converse. These are all, again, things that are going to come in handy for us. So to start us off, let's take the statement, if Howard can swim across a lake, then Howard can swim to the island. If we choose to negate this, we're going from an if-then statement where swimming across a lake is P, swimming to the island is Q. So right now we have P then Q. So if we want not P then Q, that's going to be logically equivalent to P and not Q as we have above here. So to rewrite this, we could say if Howard could swim across the lake, so Howard can swim across the lake, but in this case, we're actually converting this into more of a sentence or a slightly different version of our sentence. So you can swim across the lake, but since we're negating here not Q, so but he cannot swim to the island. Now if we look at the contrapositive, again we are taking our if-then statement to something that is logically equivalent, and this is where we have our not Q and not P, or not Q, so if not Q then not P. This is something that's comes up pretty frequently, especially depending on what level or what other math courses you take into. Contrapositive is big in proving statements. So we would rewrite, if Howard can swim across the lake, then he can swim to the island, as if Howard cannot swim across the lake, then he cannot swim across to the island. So the inverse of a conditional statement is where things start to get a little loopy. Now we're taking our same statement as above, just we keep rewriting it in other ways. So we have not P, then not Q for inverse. So we would phrase that as, if Howard cannot swim to the island, then he cannot swim across the lake. Notice it is very similar to what we have above, only now we're flip-flopping things. Lastly, with these definitions, we have the converse of a conditional statement. So if we have if P then Q, its converse would be if Q then P. And we would phrase this as, if Howard can swim across the lake, then he can swim across to the island. So again, converse, if Howard can swim across to the island, then he can swim across to the lake. With these, this is just changing our English statements back and forth between what we're working on. Again, these are all different techniques that are used long term down the road when we start proving things. This is really where it's going to come up again.